Okay, so let's tackle some harder problems that involve factorization. So what I see here is multiple x's in multiple places. That makes this automatically more challenging. I also see a common factor. There's a cosine x popping up twice. So I'm going to factor out cosine x and then say 3 sine x minus 1 equals 0. Now let me add in some instructions here. Let's say find all x in 0 to 2 pi. If necessary, round to 3 decimal places. Okay, so again, two solutions here, two branches, cosine x equals 0 or 3 sine x minus 1 equals 0, which means that 3 sine x is equal to 1. So then x here, when does cosine x equal 0? That's pi halves and 3 pi halves. And this one is not nice. So sine x equals a third. And so we're going to use inverse sine to generate my first solution. Inverse sine of a third is 0.3398. So it's going to be actually 340. And then the second solution would be pi minus that. So I'm going to leave it unrounded to do the subtraction. So I'm looking at 2, my second solution, which is actually my fourth solution, is 2.802. Okay, so x1, well, forget all the subscripts. X equals pi halves, 3 pi halves, 0.34 or 2.802. Those are my 4 solutions inside of 2 pi, which is a regular, full rotation. Let's take a look at a harder one. Sine squared x plus 2 sine x minus plus cosine squared x equals 0. Okay. So first of all, factorization is not going to work here because I've got sine x parts and I've got cosine x parts, and they're not mixed together in a way that I can kind of factor it out. Like I'm thinking of like sine x plus cosine x. If that whole thing was squared, I might have a sine squared term. I might have a cosine squared term, but then I also have a mixed sine x cosine x term. In this case, it would be 2 of those. I don't have that. I just have 2 sine x. But identities should be kind of jumping out at you, and it really depends on how familiar you are with that and the practice that you get. But here, I've got sine squared x plus cosine squared x. Well, the good news is that's 1. So this simplifies this problem quite a bit so that it's just sine x equals negative 1/2. And then I can go from there and solve, infinite solutions or whatever. Let's look at a problem which involves some higher level factorization. 3 sine squared x plus 2 sine squared x. It's not sine squared, it's squared. Minus 5 equals 0. Or how about equals 5? So the hint here is I've got sine squared and sine. That means this is basically quadratic. So that means I need to pull everything over to one side. And now I'm trying to think 3 sine x times sine x. What am I going to need to do to put in the back end to get the minus 5? So this is really like the analog here is 3x squared plus 2x minus 5 equals 0. And I could use a different variable if it helps you not confuse. There's actually a whole technique called U substitution where I say U equals sine x, and then I simplify this and then factor this and then go back to the sine form. Not necessary if you're comfortable with factorization. basically I see that I need 5 and 3s. Sorry, not 5 and 3, 5 and 1, which is going to give me 5 sine x and 3 sine x, and I can make 2 sine x out of that. So I would be minusing the 3 sine x and adding the 5 sine x. So now I've got my two branches. 3 sine x plus 5 is 0, or sine x minus 1 is 0. Both of these have solutions because I think they both, oh no, I mean actually 3 sine x, I spoke too quickly, equals -5. So sine x equals -5/3. This one you'll see provide you a domain error because there's no possibility that sine x produces an output of something bigger than 1 or -1. So this is going to be no solutions on this branch. And this one is pi halves, and there's no other solutions on the unit circle, which means if we want all solutions, it's going to be pi halves plus 2 pi n. This is a unique case where there's actually only one time on the unit circle when it happens, right? For most values, there are 2 times. We look across the circle for sine, there's 2 times that it happens, or in the terms of cosine, it's just up and down. But here and here are 2 moments when there's only 1 time in the unit circle that it happens. There's still an infinite number of solutions because if I go 2 pi n, it'll still provide me with more answers, but only one answer in the unit circle. N is any integer. Okay, well, that's kind of the basics of solving trig equations. Let me know if you're struggling with this. Definitely requires practice and a lot of underlying skills that can cause problems. So let me know where you are.